What's up, Cameron?
So,
Now the coronavirus is out.
yeah. And you got the coronavirus. Oh, great. Here comes Matthew. Man.
As I usually disclaim before we get started, if anyone does not want their beautiful face to end up on YouTube at the end of this when I upload, you might want to turn off your camera function now. As long as you can see me and hear me and communicate via chat, you don't actually have to appear on camera if you don't wish. Speaking of chat, where did mine go? No, we're not none of that. Okay, let's see how we're doing. Nice little turnout. Okay, so if you guys haven't done so, you can pull up your assignments right now so that what we do today can be more self-directed from your end, sort of like Miss Matthews have at number 7 on assignment number 2 or something of that nature. Everyone that's gonna join us before we really get started has about a minute. Oh, Tate. Okay, so
pull up the Khan Academy, or
yeah, you can do that, Carter. We can go that route. I think that because today's assignment day, probably the best way to do things is for everyone to have their actual classroom assignments open and say, okay, what about number so-and-so? Now, if you had submitted your work before today, I sent everyone comments sort of like maybe you should retry numbers 1, 7, and 4 or whatever. Unless they got 100, which I just went ahead and gave them their 100. And that is time. Okay, well, welcome everybody. Stop sharing for a second. Okay, so if you are here from the algebra end of the world, we'll be doing variable expressions upon request. If you are here from the 8th grade math part of the world, we'll be doing exponential expressions. And there's a whole bunch of laws and rules that we're going to get to. Let me check my email real quick and see if anyone sent me a screenshot or a question specifically to start off with, and then we're going to get going. Nothing that I haven't already answered. Okay. So we will start off with exponential expressions. If you have your assignments, I'm not going to do the actual problems because then I'd just be feeding you answers, but I can do problems very much similar to them. And since assignment 1 and assignment 2 are very, very similar, helping one should help the other. Now let's see. I have my own ways of. Nope, that's how I wanted. I'm gonna have to find a tutorial on how to do a whiteboard because I know it was in the options, but I haven't seen it. Anyway. Ooh. Let's see if this works. Everybody see the whiteboard? I need a thumbs up, thumbs down. Can anyone confirm or disconfirm that they can see the whiteboard? Okay, camera can see the whiteboard, and if camera can see it, that's good enough for me. All right. All right, so here's the first thing we're going to do. Exponential expressions when you have to simplify. Okay. So the directions you'll get are the words. We can do better than that. So you're going to get a one-word direction, and that is simplify. But you may get a problem or an expression that looks something similar to this. So let's say you had 8 to the 9th power over 8 to the 12th power. Okay, so simplifying exponential expressions. This is really easy to do once you get the hang of it, and it can be the worst thing in the world if you actually try to do it the long way. So what we're going to be doing here is teaching ourselves an exponential law, basically. And the abstract that we're going to be abusing is this little number. So anything divided by itself is equal to 1.
I said get out.
Okay, how about we just... Somebody's got a hot mic. It's not me. There we go. Okay. So the rule that we're going to be totally abusing is that anything divided by itself is equal to 1. So if we were to write this out, this would be the same as 1 times 8 9 times. Goodness, how many times is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 times. Let's see if I can do better. Okay, so there's 9 eighths. And then, of course, on the bottom, that'd be 1 times 8, 12 times. Ugh. Trying to be sneaky, couldn't do it. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. There it is. So what we want to do is realize that what we have here are a lot of whole number ones. And here's our fraction. 1 over 1, 8 over 8, 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 8 over 8. So we almost have everything canceling out. And that is those are the terms that math teachers are going to be using. We cancel out. So what they mean when they say cancel out is this. Okay, so anything over itself is equal to 1. Well, there's a whole number, there's a whole number, there's a whole number, there's a 1, there's a 1, there's a 1, and so on. But eventually, either the top or bottom is going to run out. So what you end up with in our case is right here. Because there were more 8s on the bottom than there were on top, we do end up with some leftover powers in the denominator. So our answer to this whole thing is going to be 1 over 8 to the third. And because let me see if I can move everything just a little bit. Sometimes I go back and I watch the stream and I realize that I wrote too far to one edge, and because I did that, you can't really see things on the far right because of our pictures. Okay, so we put you down here maybe. Get rid of you. Nah, that's no good. This is great. This is great streaming. Watching Mr. Matthews move numbers around. Okay. Nope, you go back. Okay, so here's the rule. When you've got the same base in the numerator and the denominator, so we've got 8 to the 9th and 8 to the 12th, so the base here is 8. When you're dividing, you just take away exponents. And the most we can take away is 9. So when they say cancel out, other math teachers, including myself, we're just basically going to cross these out because they just make ones. Anything times 1 is itself. That's the rule we're totally abusing. So what you end up with is 1 over 8 to the third. Okay, so now we're going to try one using that rule, and let's see how you guys do simplifying your own. So let's select all this. So if you have paper and pencil or really great brain powers, try this one. Sure, I'll just keep using that. Or how would you simplify this one? Let's say you had m to the 13th over m to the 5th. What would you get? I give you guys, I don't know, a 30-second head start before I do it. I want you to simplify this exponential expression. Okay, you've had a bit of a head start. So using our math practice standards, which I should have already pasted and I did not. 1 second. Because we're about to use repeated reasoning, and I like to have those on camera. Let's see if it works with a whiteboard. I'm not sure if it will. No, doesn't work. Okay. So what you should have gotten is you should be able to take away 5 from both of these. So your answer would be m to the 8th over 1. Well, I mean, okay. So we're overlapping rules here. That'd be m to the 8th over m to the 0. And anything to the, that's another, anything to the 0 power is equal to 1. So this would be m to the 8th over 1, which is just equal to m to the 8th. I'm just reading chat. Hang on 1 second. Aha. So a couple questions. Okay, I'm gonna answer a couple questions in the beginning of my private chat, and then but before I do that, I'm gonna show you one other way to think of these. The fraction is a division symbol, the fraction bar. So if this explanation worked, great, but here is one more way to think about it in case it helps. If I clear these out, okay, so here's another way to think about it, and maybe this will just work for some of you just a little bit better. You could rewrite this whole thing as m to the 13th divided by m to the 5th. And if you remember our multiplication rule, if this were m to the 13th, that's a 3. If this were m to the 13th times m to the 5th, we add those exponents together. That's m to the 13 plus 15th. I'm sorry, plus 5th. So you can infer that since division is the opposite of multiplication, this would be changing colors. Purple. Okay, so this would be m to the 13th minus 5. But either way, we still end up at m to the 8th. And that's how these problems, when you get the directions of simplifying an exponential expression, when it's like this, that's how it's going to work. So a couple questions I'm having pop up in chat. I'm going to answer them real quick. Let's see. Okay. While I'm going over these questions, feel free to go back through your assignments and maybe pull up something specific like, oh, why don't you go over number 7? Or I don't know how to do number whatever. So be looking at that, guys, while I answer these questions. So first question. Oh, okay. So here we go. The question is, why do you have to put the 1 times 8 times 8? Why the 1? Why the 1? So that's the question. Okay, so why do we have to put the 1 in front of that? Now, technically, you don't have to put the 1. I like to because of this teachable moment that occurs when I do it. This goes back to exponent laws. So like when you're first learning how exponents work and you hear x to the 3rd is x times x times x, well, actually, it's 1 times x 3 times. And that might not mean a whole lot at first, but it does mean a lot when we get down to this. X to the 2nd power, we 1 times x twice. And then x to the 1st power, we 1 times x 1 time. So you can see the relationship between the exponent number and how many x's we're using. And the reason I put in the 1 is for this moment. What happens when you're doing x to the 0 power? It's going to be 1 times x 0 times. So this law of mathematics comes into play. Anything to the 0 power is equal to 1. It would not matter if you had, I don't know, 397 to the 0 power. It's equal to 1. That's why I put in the 1 in every one of mine, to remind people that when you get down to the 0 power, that 1 still has to be there. Okay. How long is the video going to be? I don't know. I'll probably go for about an hour doing practice problems, but I'm going to upload it to YouTube later. So if anyone has to cut out, or if anyone could not make it because of the time slot or whatever, it will be there for you to see later. Okay, I said go and check for problems that you wanted help with. No, I don't want to save that. Let's see if anybody submitted one via email. Doesn't look like it. I don't see anybody asking in chat. So I will move right along and pick one myself. Okay. Okay, so products of products. We kind of just hinted at this one, but I'll do another one. What would you get if you had g to the 13th times g to the 4th? Sound off in chat if you know. What would you get if you did g to the 13th times g to the 4th? I think Michael wins. Someone else might be typing it. You get g to 13 plus 4, which is g to the 17th. Okay, Cameron, I'll do that one next. So let's take that same rule we just did, and let's use negative exponents. What if this was, let's use a different letter. Hang on. What if this was m to the negative 4th times m to the negative 7th? Now we're multiplying these in particular problems there, Javion. Oh yeah, Tate, you did way up there. No, kudos to Tate, Michael, Austin. Y'all got it. That's true. And Austin, I appreciate you putting in that up caret, because that is how you type exponents in a left to right form. Yeah, for those of you in chat, look at how Michael and Luker are typing their exponents. Use that up caret. It's Shift 6 on most US keyboards.
Oh.
Okay, so for this one, I'm not here. I'll type it so you guys can see what I mean. So for this one, this is m to the negative 4th times m to the negative 7th. So this would be m to the negative 4th plus negative 7th, which would be m to the negative 11th. That's how you type it in most word processors or websites or whatever. Use Shift 6 to that's how you do it. Careful, this one is negative, because you're going to be adding two negatives together, so they combine. Yep, that's a good fix. And of course, your integer rules really come into play here if you get one of each. So if you were given v to the negative 3rd times, that's a dot, sure it is, times v to the 10th, you would have to do v to the negative 3rd plus 10. And all of a sudden, all those 7th grade standards really come back to haunt you if you don't remember how to add integers together. So negative 3 plus 10 would be v to the 7th. Okay, so now I'm looking up lesson 2, question number 1. I'm on it. I can get there. Ah, yeah, sure. That's gonna rip you back into 6th grade. Okay, so here's the problem. Well, I'm not gonna give the actual problem in question. I'm gonna make one up that's very similar to it. Make this all go bye-bye. Okay, so what do you do with this? Let's see. Okay, so parentheses, negative 5 and 1/8 raised to the, goodness, I just make this enormous. Okay, well, we're going to, tell you what, just for the sake of simplicity, why don't I just go ahead and make this a 2? Yeah, that number is going to get pretty big. Exponents get very large very fast. Okay, so this is very similar to a problem on assignment 2, where you're being asked to evaluate. The directions here is one word, and it says evaluate. So step 1, and this is what I mean by you have to go back into 6th grade. The first thing I want everyone to do is remember, how do we turn a mixed number into an improper fraction? Well, there's the fast way, which is you take the denominator, you multiply it by the whole number, and add the numerator. So in your heads, what is 2 times 5? Now add 1.
11.
So this is negative 11 over 2, and nested in the parentheses being raised to the 3rd power. 2 times 5 is 10, plus 1 is 11. Now, for people that need more of a concrete refresher on that 6th grade mechanic, what just happened was this. So if you have 5.5, this 5 is really 2 over 2 plus 2 over 2, that's a 2, plus 2 over 2 plus 2 over 2. Have I gotten to 5 yet? 1, 2, 3, 4. I'll do 1 over here. All right, so there's our 5 whole numbers. That's 1, that's 2, that's 3, that's 4, that's 5. And then we still have that rinky-dink half on the end. So that's 1, 2, 3, 4, 5. Those are all whole numbers, because anything over itself is equal to 1. And I chose 2s because we could have done 3 over 3, 4 over 4, 10 over 10. But since our fraction was already in halves, I just decided to use 2s. So 1, 2, 3, 4, 5.5. Well, let's add them up. 2 plus 2 plus 2 plus 2 plus 2 plus 1. 2, 4, 6, 8, 10, 11. So that's why it's 11 over 2. And it's negative because it was a negative symbol. But some mathematician at one point just realized, hey, you know what works every single time? Take the denominator, multiply by the whole number, and then add the numerator. 2 times 5 is 10, plus 1 is 11. So, okay, fine. We've used our 6th grade skill. Now we're here in this universe where I've still got to do the exponent law for 8th grade math. Okay, so what ends up happening is you have to take the exponent and apply it to both the numerator and the denominator. So what you end up with is 11 to the 3rd power over 2 to the 3rd power. That's what you end up getting. We'll get to we'll get to this in a minute. There's the negative symbol here. We'll get to that in a second. Actually, no, we won't. I'll just put it here. We're just gonna do it in the numerator. So this will be negative 11 to the 3rd power and 2 to the 3rd power. So now 2 times 2 times 2.
Does he want me?
So 2 times 2 times 2 is 4, 8. Oh, and I might need a little help. I'm tempted to grab my calculator, but I think I can do it. Okay, so 11 times 11 times 11. So that's my number talk for the morning or afternoon. 11 times 11 times 11. Okay, well, I know 11 times 11 is 121. Should be. The 110. Yep, it's 121. So can I do, now you guys go ahead and do it on a calculator and see if I'm right or wrong. All right, so 121 times 11. So again, my number talk, this is when I wish I had my board behind me. But okay, so 121 times 11. Will that be the same as 121 times 10 plus 121 times 1. So that would be 1,210 plus 121. So I'm almost positive this is going to be 1,331. 1,331 over 8. 1, 3. Yeah, that's what it should be. Yeah, Carter beat you to it. Yeah, okay. So anyway, the principle is there. When you have a fraction being raised to a power, you must apply that power to both the numerator and the denominator. So you might end up with one that's a little more abstract, like with variables instead of real numbers. That'll save you so that way a calculator can't do it for you. Like if you were giving x squared over x, oh, it doesn't even have to be x, honestly. Hang on. Over m to the 4th, and you raise the entire thing to the 3rd power, you would have to apply that to both. So you would end up with x to the 2 times 3 over m to the 4th times 3, because that's what you do with powers of powers. You multiply the exponents together. So you'd end up with x to the 6th over m to the 12th. Anyway, that's how that would work in a more abstract fashion. Okay. Scrolling, I don't see any other requests in chat. I can check email and see if anyone sent me a picture or request. No, nothing yet. Okay. So I will pick someone else. Please, 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 if you have anything you want to ask about. So I'm going to bounce now for a second because I've just done a couple of different exponent laws. Let me check something else from the variable expression side of the world. I hope everyone's staying healthy and everyone's okay. In addition to asking everyone in chat and on YouTube to make your beds every day, I think if you haven't told your parents or your loved ones you love them or given them a big hug today, would be a good day for a hug. There are a lot of people that are in pain and suffering from recent events that I think they would really appreciate people just appreciating their loved ones at this time. Where is my link? You're still allowed to go outside as long as you stay 6 feet away from people. It even specifically said that trails and things are open. You just can't play on playgrounds and you can't get into groups. Really? How do I Tate? That's awesome. Yeah, I had to order a wheel to fix my elliptical so I could sort of run in the house because unless I'm going to strap a 5-year-old to my back, I'm not doing much distance running these days. I'm sure he ran. I'm sure he can run 3 miles. We've done it before. We did a 4-mile run at a soccer practice. And he was there, so I'm sure he can do it. He's in pretty good shape. Mr. Matthews said as he was still trying to find the problems he wanted to do. Okay, this one is more going out to one. Goodness, might only be one of you in here. But for people watching on the tube, okay. So exponential expressions just for a minute. Yeah. One quick dip into variable expressions time. So here's a problem that was for 6th period that more people missed. Oh, actually, let's do this one. So of the 5 people that got this, 0 got it correct. Not 1. So this was 20 parentheses, negative 1.5 r plus 75 hundredths. If you are in first, second, or fourth period, go look at your assignment and pick one you want to see help with. I'm going over a 6-period problem. That's really horribly written, but it's there. Okay, so what we have to do on this one is we need to multiply the 20 times both terms. That means we've got to do negative 1.5 r times 20, and then we'll add that to 0.75 times 20. And then now, yeah, you could probably just rip out the calculator, but I like to try not to do that if I can. So this would be, well, this would be negative 1.5 r times 2 times 10. So 1.5 times 2 is 3. So that'd be negative 3r times 10. So this would be negative 30r plus 0.75 times 20. That'd be the same as 0.75 times 2 times 10. 75 cents times 2 would be $1.50. So that'd be 150 times 10. And then move the decimal over, so that'd be 15. 75% of 20, yeah, that'd be 15. So the answer, and it doesn't get any simpler than this, really, is negative 30r plus 15. So there's that. And that is one that, of the 5 students that got that one in their random queue, nobody got it right. Okay, I wish I didn't have to stop to discuss chat. I wonder if I can just prevent some of you guys from chatting. If you're not going to chat about math, you really just don't need to be here. You are invited to leave. You can watch the replay later. Oh, here, hang on. I'm just gonna mess with this. This is the first time I've even considered doing this, but okay, I think that worked. Okay, so I guess I got to make policy now. So the moment you are rude to someone in chat, you can only talk to me. There, cool. So I don't have to boot people. I can just limit who you are allowed to talk to. At least I hope that works. Anyway, we'll see. All right. Let's see. Has anyone picked a problem to do? I haven't seen anyone request a problem, so I guess I get to pick the next one again. Okay, I like these. These require a lot of critical thinking. So what do you make of this, chat? So I'm going to give you a number, like a line. And this is just information you're going to need to solve the problem. So I'm going to put 3 here, 2 here, 1 here, 0 here, and negative 1 here. And then I will put M there, and G there. Now, from this image, you don't even have to know what M is worth. You don't have to know what G is worth. Just right now, see if you can figure out if they are positive or negative. Okay, so M, what do we agree? Is it a positive number or a negative number?
Positive.
What about G, everybody? Is G positive or negative?
Negative.
Okay, so that is stuff you have to pull that for yourself. A calculator will not help you do this. You just got to look at the number line and make sense of it. Now, that is not the question. The question, you aren't going to get any points for declaring that. Now you need to use that information to solve a problem. So if I were to say, if I said M to the 8th times G to the 5th, and I don't want to know what the actual answer is this going to be positive? Is it going to end up being negative? Or is it going to end up being equal to 0? That is the question. This whole expression.
0.
Well, that's the debate. What you're really being asked to do here is to decide, is M to the 8th, wait, that's not what I wanted. Is to decide, is M to the 8th, is this going to be positive or negative? Is G to the 5th, is this going to be positive or negative? That's the question. So M, we agreed that M was a positive value. So if M is 5, 7, 10, a million, it doesn't matter. If it's a positive number raised to the 8th power, it's still going to be positive, even though we don't know what the actual number is. But here's the debate. G to the 5th. If G is a negative number and we're raising it to a 5th power, does it come out to be a positive number or a negative number? That's the question.
Positive.
Okay, so I got one person named positive. Does anyone disagree or agree?
Positive.
Okay. So we have a request via email. We'll get to that next. Okay. So let me tell you why you're wrong. It is definitely gonna be negative. Here's how it works. Look right here. Is 5 even or odd?
Even.
So
Odd.
the
No, wait, odd.
even numbers are multiples of 2. 2, 4, 6, 8, 10, 12, 14. Those are all even numbers. Odd numbers skip in between those. 3, 5, 7, 9, 11, so on. 5 is an odd number. I'm going to come back to that in a minute. So there is an abstract law that a negative number times another negative number is going to equal a positive product. So hopefully you guys can remember this back from 7th grade, that when you multiply two negatives together, you get a positive answer. Okay, that is really important here. When you multiply a negative x times a negative y, you just get whatever they are multiplied together as a positive answer.
I got a question.
Now, what's up?
Is you gonna be streaming tomorrow too, as well?
Nope. You can find someone else to stream on Saturdays. This was gonna cap off like 6 or 7 hours of content I've done this week. That's enough for me. Saturday I've got other things to get doing.
So if you do a negative x times positive y, would it be negative or positive?
Yeah, okay, that's a great question. I believe what you said was if we did negative x times a positive y, just a normal old y, the answer would be negative. It'd be negative their product.
Okay.
Yep. So If you have one of each, they come out to be negative. But if they're both negative or both positive, they come out to be a positive product.
Look at me.
So now we still need to use that rule up in our actual problem. Okay. So G is a negative number. If we're doing G to the 5th, that's 5 negative values. That's 5 negative values. So that's negative G. Let me get a different color. All right, so that's negative G times negative G. Actually, I shouldn't even say negative G. They're just negative numbers. So that's a negative number times a negative number times a negative number times a negative number. 1, 2, 3, 4 times a negative number. Now, according to our little rule down here, every time we multiply two negative numbers, it makes a positive product. Every time we multiply two negative numbers, it makes a positive product. But we have an odd number. So since G is negative, and we have 5 of them, it's going to come out to be a negative answer. If this had been an even number in the exponent slot, we'd have a positive outcome because every 2 numbers would make a positive product. And that just takes practice to hammer home. But we haven't even answered our question yet. Okay, so if m to the 8th comes out positive and g to the 5th comes out negative because g is a negative number and we're doing it an odd number of times, then the entire answer is going to be negative. That's how you solve these. This is one of the last questions on assignments 1 and 2. And then no calculator can help you. It is just all logic. First, you identify if they're positive or negative. Then you sort of insert that logic into the expression they give you. And knowing your integer rules and exponential rules, you figure out, okay, well, if these would have to be positive and negative and I'm multiplying them together, then even though I don't know what the number is, it would come out to be a negative answer. Okay, I got a specific request via the emails, so we're going to do that one next. I could have hit one button and just cleared everything. That's smart. Okay, here is the request I just got. I'm not going to give you the exact one because it'd be on the quiz, but one very similar. So y equals negative 10 x minus 5. Okay, so here's what I'm going to ask you, true or false?
True.
Lol, I haven't asked anything.
False. False.
You guys are so funny. Okay,
False. False.
so remember that.
Doesn't even say anything.
Yeah, they just thought they'd say something. Okay, so remember that coordinate pairs come in x, y. So if x was 2, would it be true or false that y would be equal to negative 10?
False.
Chris, come on.
False.
I just said
Okay,
that.
so there's a way to test it.
It's false. I just said that.
Okay, well, why? Can you explain why? Or are you just blurting out a word?
It can't be negative 10 if negative 10 is already in the equation.
Yeah.
That's interesting. I don't even know because I haven't worked it out yet. But what you do is you take these values for x and y, and you can substitute them into the equation to see if it works. So in this case, I would say that negative 10, see how it's in the y slot? So I put it in the y slot, equals so negative 10, which is y, equals negative 10 times x. And we said that x is equal to 2.
Yes.
I got to move this over, else it's going to be in our pictures. Hang on. Minus 5. So what I did is I substituted in values for y and for x based on the coordinate pair that we were given. So this would be negative 10 equals, okay, so negative 10 times 2 is negative 20
Negative 20.
minus 5. So negative 10 equals negative 20 minus 5. That'd be negative 25. Is that true or false? So in this case, it would be false because negative 10 does not equal, like these two things do not equal. Yeah, I'm going to be streaming till about 4 o'clock unless someone gives me a very specific question and I'll keep going. But these questions usually give you 2 coordinate pairs to choose from. So let's test one that might actually work. Hint, hint. So what if x was equal to 3 and they claimed that y was equal to negative 35? And I had to test whether it was true or false. That doesn't really, anyway. So what we would do is we would write the equation again, but we would actually substitute in these numbers for y and for x. So let's try this. So that would be, if this is our y value and this is our x value, that would mean that negative 35 equals negative 10 times x, and x in this case is 3, minus 5. So negative 35 equals, okay, so negative 10 times 3 would be negative 30 minus 5. And yeah, negative 35 would equal, negative 30 minus 5 is negative 35. So when they come out to be the exact same thing, that's when it's a true statement. So good request. So that's how you do those. They'll give you a couple different coordinates, and sometimes one is true, sometimes the other is true, sometimes they both are true, and sometimes neither one is true. But that's how you do those. You just do some substitution and then attend to precision while you're doing your arithmetic. Okay, it is 3:55, which means we've been almost going for an hour. Some of you have been in chat longer than that. And I'm just going to say, unless someone has a specific question, like, hey, can you show me one like number so-and-so? I think we're done for the day. All assignments, the two classroom assignments were due today by midnight. It's ominous to say by midnight.
I have a question.
All right, which one?
Lesson 2 from the one that you posted on like April 6th, question 1.
Yeah, okay. I did one like that earlier, but we'll just do another one.
Okay.
Let me clear all this out. Wait, there's one button. Clear all drawings. Okay. So assignment 2, the one that it was a negative mixed number, right?
Yes, sir.
Okay. All right, so let's say you had negative 2 and 2/3. Sure. You can raise the second column. Yeah, if you guys have a lot of background noise, just go ahead and keep yourself muted. In your options, guys, there is a button to temporarily unmute yourself. So if you just had something to say, you could press the button, say something, and then unpress the button or release the button. and then you only say what you need to say. Okay, so this is very similar to the first problem on assignment 2 this week for exponential expressions, 8th grade math. And step 1 is you have to turn the mixed number into an improper fraction. So the fastest way to do that, which is just the shortcut, you multiply the denominator times the whole number, and then you add the numerator. Now, if you want to see the full length explanation of this mechanic, just wait until this is on YouTube and then scroll back to one of the first problems I did, and you can see what I'm explaining. So this as an improper fraction, 3 times 2 is 6, plus 2 is 8. So this would be negative 8/3 being raised to the second power. 3 times 2 is 6, plus 2 is 8. Yep, be negative. Okay. So now the law says that we're going to do this exponent to both the numerator and the denominator. So what you end up having is negative 8 raised to the second power over 3 raised to the second power. If you're asking me why the negative goes with the numerator, just because I said so. You could do it with the denominator, but just I think it's all simpler just to leave in the numerator. So negative 8 times, so this would be negative 8 times negative 8. And yes, if you were to scroll back, you'd know that I'm really wanting to say this. This is 1 times negative 8 twice. And this is 1 times 3 twice. I think I'm getting a little close to our recorded picture. So give me 1 second. Let me scoot this over. Okay, so now we go back to our integer rules. What is negative 8 times negative 8? Is it positive 64 or negative 64? Negative 8 times negative 8. Chad is dead. Yes, it is positive 64. And then what is 3 times 3? 64 ninths. And you can leave it like this. Some people I've noticed are turning in assignments with like the decimal answer. I'm perfectly fine with you leaving it as an improper fraction. So 64 ninths. Okay. So last chance, it is 3:59. Anyone have a specific question about a problem from the assignments that I can go over before I post this on YouTube?
Nope.
He speaks for everyone.
Mr. Matthews,
Hey,
how you been doing? You been doing good?
I've been doing great, Javion. How are you?
Good.
Okay. Well, that's going to wrap it up for this session of exponential expressions and just a slight dip into variable expressions for the algebra kids. No one else asked me specific questions, so I guess we're good to go for now. Make sure you actually submit your attached work for the assignments to make sure I get grades in. I'll probably start looking at the grades tomorrow. They will not be posted in iNow like normal. We're gonna be keeping track of things a little bit differently. But you will see me post the grades on Classroom, so you can keep track of how you're doing that way. And that should be going out tomorrow since I'm giving everyone all day today to do their
What
work.
you doing? Paris, no. What you doing?
Mute buttons are awesome. Okay, so take care of yourselves, take care of your families, and like I said, make your beds every day, and make sure you tell people you love them because you never know when you get another chance.
I have a YouTube channel.
Love you guys. See you next time.
Bye-bye.
Yeah.